Okay, now we're talking about left rectangle approximation method. Very similar to right hand, except for now it's touching the graph on the top left corner of the rectangle. That's pretty much it. Now that is going to change a couple things about how we calculate our heights and our delta x. Actually, we're going to calculate those things the same, but it's going to just kind of change how we use it. So look here. And again, we're just finding the area of a rectangle. Review on how to find your delta x. And so we have these same questions. Now we're going to find our delta x of these two. One with 2 rectangles, one with 4 rectangles. The process here, pretty straightforward. Once again, it's b minus a over n. And remember, that's your n value right there. And this is your a and your b. So let's just do it real quick. Pretty straightforward. You get 4 over 2, which is 2. Here you get 4 over 4, which is 1. So we have our delta x for these two scenarios, and we're going to use these for these two problems. So you'll notice that this problem is the same as this one, so we can just copy and paste our delta x is 2. And on the next page, you can know that that question's delta x is 1. So let's get right into it. Let's take a look at what this graph would look like. Again, it's just a parabola. We're going from 0 to 4. And since our delta x is 2, that means we're going to have a point that we evaluate right here in the middle at 2. So here's your first change in x and your second change in x, or delta x. Now, the fundamental difference here is we are approximating with a left-hand rectangle. So when I go to draw this in, now the top left corner should hit. Well, the top left corner here is at 0. Then top left corner here is at when x is 2. So this is pretty simple to evaluate. So let me start off again by just kind of showing you the basic formula here for LRAM. It would be delta x times, well, the first thing you're going to plug in here is f of your a value, right? Remember, that's your a, because it's on the left side, plus f of a plus your delta x. And if there was more terms, this one's only going to have 2, because there's only 2 rectangles, but it would keep going until you get to f of, not f of b, it'd be f of b minus 1 delta x, because since you're touching on the left, you're never going to get to f of b, right? But you can always get one change of x away from b. Okay, well, like I said, this one only has 2 terms, so really it will be these 2 terms in my expression. So let's kind of write that out. It's going to be the delta x times the f of a here would be f of 0 plus, and there's 2 ways of thinking this. You could say these 2 are the same in this situation, because if I did 0 plus 2, I get to 2, and if I do 4 minus 2, I get to 2. So either way, it's f of 2. All right, let's plug everything in. Delta x, like we said, is 2. F of 0, 0 squared is 0, and 2 squared is 4. So this is just 2 times 4, which is 8. So we've used the left rectangle approximation method to see that the area is approximately 8. And if you remember from the other video, when we over-approximated, we had, with 2 rectangles, we got 40. So we know it's somewhere between 8 and 40. And then on the next one, we'll get a little bit closer because we're going to do 4 rectangles. So let's go ahead and go to the next one. Remember, we already calculated that the delta x on this one is 1. So let's get right to it. Here's a graph. Here's a parabola. And now we're going from 0 to 4, but we're going to evaluate at every delta x of 1. So 1, 2, 3, and 4. Let's do our rectangles. Left approximation, so it's going to touch on the left side. So this first one just touches at 0. The next one touches when x is 1, x is 2, and then when x is 3, and that would be the last one. So again, how would we what's the basic layout for this? This would be delta x times, and this would be f of a plus f of a plus delta x plus f of a plus 2 delta x. And then finally, this last term is going to be f of, it would be a plus 3x, 3 delta x I mean, Or this last term could be f of b minus 1 delta x, because we're saying it's the last one. It's the last one before we, 1 delta x away from our b value. These two are the exact same. So let's kind of plug in what that would look like for ours. It's going to be delta x times f of 0, and our delta x of 1, so we just keep adding 1 every time now. F of 1, f of 2, and then f of 3. And that makes sense here that these are both 3. That's kind of what I was getting at here, because our delta x is 1, so 0 plus 3 is 3, or 4, because our b is 4, minus 1 is also 3. So either way, we know we're going to end at 3 here. Let's plug in what we know. We know that the delta x is 1. We know that f of 0 is 0. F of 1, 1 squared is 1. F of 2, 2 squared is 4. F of 3, 3 squared is 9. We add all that up and we get 14. So we could say the LRAM of this guy, 4 rectangles, is 14. Okay, if you remember from the last video, when we did an approximation method of this with right-hand rectangles, we got an approximation of 30. So now we know it's somewhere between 14 and 30, and you can see how we're getting closer and closer. And if we were to add 8 rectangles, we get even closer, and 16, and so on. And if we were to add 100 rectangles, we get really close. And so we can see how we're getting closer and closer as we go. All right, see you guys on the next video.